All right, number 9. So in number 9, we don't have to sketch this one. Thank goodness. So, but it's good to graph. It's good to sketch. It's good to draw a picture. Sometimes it's a little tedious. So from -3 to +5, the cube root of x, subtract a half, dx. And we're going to use 4 left rectangles whose width are determined by an interval. Now this is far more AP exam-like, where the rectangles aren't all the same width. So if we're going to do 4 of them, the first width goes from -3 to 0. So the first width is 3. So from -3 to 0, that's 3. And if I use a left-hand one, I plug in the left value. So if you plug in 3, it would be the cube root of -3, subtract a half. Do not simplify it. The next width would be 0 to 1. That's 1. Zero to 1 is 1, and then plug in the left one, which is 0. That's just negative a half. So you can see what I'm doing again. So I'm doing each rectangle separately. So length times width, each one separately. So the first one was 3 by this. The next one was 1 by negative a half. And just each one separately. So 1 to 2 is 1. And then the left height, you plug in +1. You don't have to simplify it, so just write it in. And then the last one is 2 to 5. That's 3. And then use 2. And that's what it looks like. So each rectangle was done separately because there wasn't an equal width. So what's the distance between the x values? Gives you the width. This gives you the height. Don't even bother to simplify it. It's done. Number 10. All right, calculator, I can do that. So use a calculator to evaluate these. Take out your calculator. So number 10, and then I'll show you how to put it in radian mode if it's not. So number 10, we're going to press menu, then we're going to press menu, then we're going to press calculus, then we're going to press integral. We're integrating from, what is it? I'm just looking here on my other computer. -4 to 5. And then what's the integrand? 3x cubed. Subtract 4. And that is to the exponent. Oh, I should have started with parentheses. Let's try it again. Because it's all being to the exponent 10, right? So it's 3x cubed. Subtract 4 to the exponent 10. And that's dx. All right, there it is. Control Enter. Took forever. Now, be careful here. So you need to write that in, because the number is so small, actually so big, you need to write it in scientific notation. So that means 7.88 So that means 7.888 times 10 to the 24. That's scientific notation. This calculator does it. So if you ever see that, then you know what that is. Number 11, it has to be in radians. So let me just show you that quick. So to know if this is in radians or not, you're going to press the document button. That's the one on the right, top right, document, then settings, then document settings. See the second one? You just go down to the second one, and then you could change it and then press enter. And they go, yep, apply this thing, and then it's done. So, and if it's radians, obviously, what will it be up here? It would be RAD if it's in radians. All right, so what am I integrating again for the next one? Or for number 11? Oh, it says find the second derivative of sine x at pi 6, pi over 6. All right, so how would I do that with my calculator? Press menu, press calculus. This time we're doing the derivative. So the variable is x. What value is pi over 6? Pi is on the bottom left. So there's pi. And then control divide gives you a fraction, or there, pi over 6. So there's the number. Now it's the second derivative. So go to the second derivative and then press enter. And press OK again. So that's what it looks like. And then inside the parentheses you would type in sine x. So press the trig button. Trig is right beside the number 7. Make sure you put the variable in there. So there's sine x. It's all set up for you. Control enter, super simple, and the answer is negative 0.5. Number 12. So for number 12, this is find the area between 2 sine x and the x-axis in that interval. So in other words, first of all, do the integral setup. So we're integrating from pi over 2 to pi. What am I integrating? 2 sine x dx. And then put that in your calculator. So there's the setup to find the area. And then this is what it's going to look like. So menu, calculus, integrate. So we're going to go from pi over 2 to pi, and then what's the integrand is 2 sine x dx. There's your setup. Control, enter, and you get the answer 2. Done. So, do you have the ability to use your calculator to do some calculus? Yay. All right, what number are we at now? All right, use the graph of y equals f of x at right to graph each of the functions from problems 13 to 16. So this is not even calculus, it's just practicing transformational stuff. So let's see if we can do that. So in number 13, it's y equals negative f of x plus 1. So I'm going to take each key point. So that's negative 2, 0. That's 0, 2. That's 2, 0. And 4, negative 2. So that's each of the key points. And I know the first two make a quarter of a circle. So take each key point that I see on the graph and transform it. So if it's a negative and adding and subtracting, this is all in front or after the function. This only affects the y coordinate. So the x coordinate stays the same. If something happens inside the parentheses, then x changes. The y coordinate, I'm going to go times negative 1 and then add 1. So 0 times negative 1 is 0 plus 1 is 1. 2 times negative 1 is negative 2 plus 1 is negative 1. 0 times negative 1 is 0 plus 1 is 1. A negative times a negative is positive 2 plus 1 And those are the ones we're going to graph. So -2 and 1, 0 and -1, 2 and 1, and 4 and 3. Now this is going to make a line. And this is going to be, now remember it's been reflected, the quarter of a circle. So it's now going to curve like this, because it's been reflected down. So it has that curve and then a line, and that's what it looks like. That's number 13. For number 14, it's the absolute value on the outside. Do that. So the first thing, so I'm going to write it down. So the absolute value of 5x, f at x plus 1. And again, write down the key points. So -2, 0, 0, 2, 2, 0, and 4, -2. And then note what happens on the outside affects the y coordinate and inside affects the x, and it's the opposite of what I see, or the inverse. So we're going to subtract 1. Subtract 1. That'd be -3, -1, 1, and 3. So subtract 1 to each x value. The absolute value bars changes all of these to positive numbers. So if there's 0 or positive, they just stay the same. So really the only one that changed was this negative value. So we'll start with -3, 0, -1 and 2, 1 and 0, and then 3 and 2. So once you notice that this kind of creates a V right here. So it was a line that went all the way down, but the part that was negative got reflected up. Here, this is your quarter of a circle here that kind of looks like that. The next one is y equals 2f at -x. Again, the same points, so I'll show you the setup. So really the key is to understand how to transform points. And do you see the transformation in front of you? So what's on the outside affects the y coordinate, inside affects the x. So we're dividing by -1, so it creates a reflection. So take each x coordinate and divide by -1. Take each y coordinate and multiply times 2. So you're going to have a reflection over the y-axis and a stretch. So 2, 0, 0, 4. That's going to be that curve. That quarter circle now is on this side. -2, 0. It's going to be a line. And then -4, -4. That's going to continue that line there. So there it goes, -4, -4. So you have your line and your quarter of a circle. All right, let's look at number 16. So in number 16, you have y equals f, and then you have parentheses, the absolute value of x divided by 2. So we're going to start it the same way. We have our key points from the graph we're going to write down, and then we're going to transform each point, and then we'll graph it from there. Here. So those are my key points again. So notice nothing is on the outside of the function. Nothing in front, nothing behind it. So the y coordinate is going to stay the same. For the x coordinate, you do the inverse of what you see. So we're going to multiply times 2, and then the absolute value bars just makes all the x values positive. So negative 2 divided by 2 is negative 1, and then the absolute value makes it positive 1, and the y stays the same. Again, for 0 divided by 2 and the absolute value of 0, it stays 0, and then 2 would stay the same. Here, 2 divided by 2 is 1, and the absolute value of 1 stays 1, and it stays 0. And then 4 divided by, why am I dividing? Again, multiply. So 2 times 2 is 4. This should be a 4. Negative 2 times 2, and absolute, this should be a 4. After saying that, it's the inverse of what you see on the inside. Times. So you multiply it times 2 and then the absolute value. So this would be 8 and the absolute value. And then the y coordinate stays the same. I know. Okay. And for the absolute value of the x, in terms of what's happening, you really only have to graph the right side, and then it gets reflected over. So this is what it would look like. So counting to 8, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 and negative 2. We have 4 and 0. We have 0 and 2. Now, the thing with absolute value, it's a little tricky. For the x value, when the bars are on the inside, notice this is all on the right side. If I plugged in negative or positive numbers, it would end up being the same picture, but on the left. So I'm just going to, it's a reflection. And there you go. This should have an arrow. This should have an arrow, right? And an arrow at one end. This here. This should have an arrow. I think there's an arrow at one end, right? I didn't do the arrows. Right? Yeah, there's an arrow. Okay, so I'm going to do a second video on 13 to 20, whatever, 27. So, Mr. G Math over and out. I'm proud of you for doing your work. There's part 1 done. Take a break, and then you can do part 2 when you have the energy to do it. Always ask me questions. Keep fighting to figure it out, and I believe in you. All right? Mr. G Math, till next time.